Welcome everyone to this Google Hangout about NASA's Operation IceBridge. IceBridge is NASA's ongoing mission to fly planes over Earth's north and south poles to study ice. I'm Laura Betts, here at NASA's Goddard Space Flight Center. We're very fortunate to have two guests who are just on an IceBridge flight to Antarctica. U.S. Ambassador Michael Hammer, who is the U.S. Ambassador to Chile. Honored to have you with us, Mr. Ambassador.
It's a pleasure to be with you. Buenas tardes. Un gusto estar con ustedes.
Also on that flight, we have NASA's chief scientist, Dr. Ellen Stofan. Welcome, Dr. Stofan.
Thank you. It's great to be here today, but I have to say it was even better flying over Antarctica yesterday.
Both Ambassador Hammer and Dr. Stofan are joining us from Chile, the jumping-off point for NASA's flight to Antarctica. From the University of Washington in Seattle, Ben Smith is a senior IceBridge researcher. Ben, thank you for joining us.
My pleasure.
We're answering your questions. If you're watching live, just use #IceBridge. And our first question is for Ambassador Hammer. Mr. Ambassador, you have been previously posted in Bolivia, Norway, Iceland, and Denmark, and have also served at the White House and the National Security Council. How and why does the State Department support science?
Well, thank you very much for that question, and it goes to the core of part of our mission at the State Department. Obviously, our focus is to explain America's foreign policy and to promote American interests, but science is a very key component of what we do, in the sense that we know that through science we can solve the world's challenges, and we also know that as a country, the United States can't solve the problems alone. And so science means that we can work with other governments to confront, for example, the current crisis on Ebola, to confront the challenge of climate change that we were learning about yesterday through our IceBridge mission. And so even at times when, because of political reasons, perhaps there's tension between countries, we find that scientists still find that it's easy and wanting to communicate on the issues that are relevant. And so it's another vehicle through which we, the United States, can be contacting other folks and connecting them, because science, at the end of the day, is as I said, important to the United States, but to the world, and it's a way that we can solve the problems that we currently face for the benefit of future generations.
Thank you.
I should also note that we know that science and technology are important for creativity, innovation, and they help with economic development and growth, which is another core mission of the State Department, promoting American business and investment, but also through innovation and creativity, which the sciences attract very important groups of people, and through education we are able to, again, advance another one of our core interests.
Thank you. We have another question for you, Mr. Ambassador. What is science diplomacy?
Well, thank you very much for that question. We have been doing science diplomacy under the Obama administration, first under Secretary Clinton, and then now with Secretary Kerry, because what it means is that we are, again, connecting with people in a way that they can relate to the United States. We find that science breaks down a lot of barriers. People are problem solvers. We find that it's a way that, again, we can gloss over some other political or economic tensions and be able to engage with a broad audience. And let's touch on education, which is critically important, we know, for future generations. People are attracted to the work of NASA. They're attracted to our universities. I'm sure even the University of Washington gets a fair number of international students. And we want to attract the very best from around the world. And what better way than to highlight what we are able to do in the science field and to generate that international cooperation that promotes better relations between countries. So we don't only have government-to-government contacts. We want to have scientists like Dr. Ellen Stofan with us, visiting here in Chile, connecting with students, as she has been during her visit, connecting with people at the Antarctic Center here in Chile, and fostering that positive feeling that allows us to then cooperate when problems arise.
Well, thank you. Speaking of transcending borders and other cultures, Ellen, your research has focused on the geology of Venus, Mars, Saturn's moon Titan, and Earth. What is NASA's role in studying the climate and polar regions in general?
You know, a lot of people wonder, you know, why does NASA study the Earth? Well, for one thing, the Earth is a planet, and of course it's our favorite planet. And by studying the Earth from space, you really get a global view, and that global view is what you need to study so much of the Earth's, how the Earth works, because you have to pull back from that distance to really observe processes that are operating on very large scales. How do the oceans work? How do they interact with the atmosphere? What is the state of health of the polar caps? And of course, due to the fact that our climate is changing, it's getting warmer, that is affecting the polar caps. We've had record melting in the Arctic over the last 10 years. The Arctic ice cap gets smaller and smaller in the summers, exposing a lot more dark ocean, which certainly is affecting climate and ultimately weather. And in Antarctica, some of the ice sheets are not very healthy. They're in a state of collapse. And so we need to monitor this from space, or we can use aircraft like we do with IceBridge to go out and fly over the planet, make the measurements that we need to make to truly understand how the planet is operating. We need that from a practical point of view. How can we better understand our climate and how that affects our weather so that we can help people here on Earth?
Our next question is for Ben. Generally, what is Operation IceBridge?
Operation IceBridge is an effort to bridge the gap between two NASA satellites, IceSat-1 and IceSat-2. Now, both of these satellites are altimeters. They measure the height of the ice sheet. IceSat-1 finished in about 2009, and IceSat-2 should launch sometime in 2017. So these were both really valuable missions for telling us what the ice sheets were doing. They showed us that the ice sheet heights, the IceSat-1 showed us that the ice sheet heights were sinking in a lot of places. And IceSat-2 will continue that series of measurements when it launches. But in the meantime, we have sort of a gap in the data. And so we're filling that gap by flying airplanes that make the same kind of measurements as these two satellites. Now, of course, you can't fly an airplane everywhere all the time, so we've had to be a little bit smart about where we're going to send these airplanes. So we've focused on some important areas. One of them is the part of Antarctica that's closest to South America. So the Pine Island Glacier and the Thwaites Glacier are really exciting places because they're changing a lot. And some other places are in Greenland, where we know that glaciers are changing really rapidly. And then beyond getting those places, we try and make the measurements everywhere else we can as best we can. Now, since we're flying these airplanes with the laser altimeters on them, we might as well put some other instruments on the airplane at the same time and get a little bit more bang for our buck. So among the instruments that we have on the airplane is an ice-penetrating radar, which tells you how thick the ice is, which is really important for being able to make predictions of what the ice sheet is going to do in the future, and for understanding how speed changes in the ice sheet affect sea level. And there are some other measurements that tell us how much snow is on top of the ice sheet, how much snow has fallen recently, and how much snow has fallen in the past, and some instruments that tell us about the temperature of the ice, and if there's open water, the temperature of the water. So it's an airplane that's festooned with all sorts of great instruments, and it's really producing fantastic data sets that have really helped us know what the ice sheets are doing and what they might do in the future.
We have a question from Twitter at Flortorian. How does one navigate down there given that east and west is near meaningless and everything is north view? Ben, would you like to take that?
Yeah, navigating with GPS in the poles is really not that hard. You start out with a map that has Antarctica in the center of the map, and then you just draw the lines that you'd like to fly, upload those to your GPS, and the GPS will take you where you need to go. So if you're doing this with a compass, it can get really confusing, and that's because a compass will always point north, and in fact in Antarctica a compass will point in a lot of different directions because the magnetic field is kind of complicated down there. But with GPS satellites, it's pretty straightforward.
Ben, another question for you. How do these changes to the ice in polar regions impact us thousands of miles away?
Well, the one that we're always the most interested in is sea level change, because that affects the whole planet at once. So as ice leaves Antarctica or leaves Greenland and goes into the ocean, unless it's replaced by new snowfall, that's going to make the ocean levels rise. So for just back of the envelope calculations, 360 cubic kilometers of ice removed from Antarctica and added to the ocean equals 1 millimeter of sea level. We like to make measurements in places where we know that the ice sheet is changing rapidly because it's easier to have measurements that are greater than the errors, but we also like to know what the whole ice sheet is doing at once. So once ICESat-2 is up, we'll have sort of ice sheet-wide measurements, but for the meantime we're looking at the places that are changing the most rapidly because those will have the greatest impact on sea level in the short term.
We're still collecting questions at #IceBridge. Here's another one for Ellen. Why is it called IceBridge?
Well, because it studies the ice. Again, in the North American summer, we go up to the Arctic, we go up to Greenland, look at the extent and thickness of the Arctic ice cap. Then we go to Greenland, make lots of measurements in that area to understand the state of the Greenland ice sheet. Now it's down here in South America. It's spring going towards summer, so we bring the aircraft down here and fly over Antarctica. So we're studying ice at both poles, and we're bridging, IceBridge, the gap, as Ben was talking about, between ICESat-1 and ICESat-2. And it's actually a really great opportunity because when you have instruments on an airplane rather than up in space, you can keep improving them. You can keep thinking, as Ben was saying, what other instruments can we bring along with us? It's easy to swap things in and out. So it really allows us to optimize the instruments, really get at how can we make bring the best instruments along so that we can really understand what's happening in these polar regions where climate change is making things change just so rapidly.
We have a Twitter question from @FitOrion. What data are you collecting with these flights? Ben?
There are quite a few different instruments that are on the airplane. One of the most important is the laser altimeter measurements, and that's just where you send a pulsed laser down to the surface of the ice and measure the time it takes to go from the airplane to the ice and back. That tells you how high the surface of the ice is. And if you measure that more than once, if you measure that this year and next year, you can see how much the surface of the ice has gone up or gone down. The other measurements we have are from radars. So one radar system measures the thickness of the ice. It sends pulses of radar energy that travel all the way through the ice sheet, bounce off the bottom, and come back to the airplane. So if you know the time that takes, you can figure out how thick the ice is. Another set of radars measures the ice right near the surface. So it measures the snow layers that are right close to the surface. If you see how thick those layers are, you can tell how much it's been snowing. And that tells you how much snow has been added back to the ice sheet. These things also operate over sea ice, and they can be used to measure how thick the sea ice is and how thick the snow on the sea ice is. And then we have some other measurements that tell about the temperatures of the surface and the temperature of the atmosphere. We have measurements that, we have cameras that take pictures of the ice below the airplane. And we have some measurements of infrared radiation around the airplane, which are important for understanding how sea ice forms and grows. So that's the mission in a nutshell.
Thank you. Ellen and Michael, what was it like on the flight yesterday?
Wow, that's a scientific explanation. No, frankly, it was really, truly remarkable. One dreams of perhaps someday being able to see Antarctica, but actually doing it is really an incredible experience. And also to learn from the crew and the incredible scientists that are on the board as they were explaining to us exactly what was going on. So it's not only the sights, but also the remarkable effort and science that's behind all this. So for me as a diplomat, here I was learning things that you were very curious about, but to see it in real life and to see the natural beauty is really quite spectacular. And you're seeing some of the images there in the background. Well, it truly is like that. Just this incredible expanse of ice, and then the mix with the water and the mountains that you see is really phenomenal. And I certainly had a great time. It was 11 hours, but it seemed to go by in a flash because we were sort of busy trying to absorb it all and learning really what's going on. And the incredible diversity of the crew, in fact, of the people that were there from different parts of the country, different backgrounds, all working together to try to really understand the science behind climate change and the impact that eventually will have for policymakers as we feed them the data so that they can make smart decisions. And it's something, again, we appreciate Chile's cooperation in this and letting us do these missions out of Punta Arenas where we are here today.
I think the thing that surprised me the most about the trip yesterday was, first of all, how smooth it was. My children can attest to the fact I'm not the calmest airplane flyer in the world, and this was probably the smoothest flight I have ever been on. The pilots were amazing. And then just being able to look out the window and you see the beautiful Antarctic continent, the ice surrounding it, and just thinking about the impacts that humans are having through putting greenhouse gases into the atmosphere, causing these immense changes that are occurring at our poles. It kind of reaffirmed to me that certainly at NASA we need to continue making the best measurements we can to understand how climate change is affecting our planet. But certainly, again, this idea that it's our responsibility to help protect this planet also.
So we're very fortunate to have one of NASA's video producers here who has been on 5 different IceBridge tours. This is Jefferson Beck here with us today. And Jefferson, could you tell us a little bit about what a typical day is like?
Sure. Well, we've heard a little bit about it already, but basically you're waking up at very early. You're in for a long day, but it's an exciting day. Waking up or heading out from the hotel about 5 in the morning, heading to the out to the airstrip, and you don't know if you're flying at all, and you don't know if you're going to be flying over beautiful sea ice formations in the Weddell Sea, for example. You can see a shot of the aircraft right now taking off from Puenta Arenas, a little bit sped up, as you can tell in this first shot. And you make the long 3 or 4 hour transit to your science area, then you spend about 5 or 6 areas combing back and forth, getting the data you need. Here are some of those beautiful sea ice formations I was referencing. You might see some beautiful icebergs there stuck in the sea ice, which is the frozen seawater, or some giant tabular icebergs. These guys that you're seeing now are 50 meters thick, perhaps, and a lot thicker below the water and as big as a runway. Or you could be flying over a land ice mission, seeing these crevasses. They flew around the South Pole a couple days ago, did a little loop, I think, at 88 degrees, over the Pine Island Glacier, some pretty stunning scenery. This is the edge of an ice sheet where it meets the ocean, again meeting sea ice there at the edge. Or, it's one of my favorite parts, is flying over the Antarctic Peninsula, where you can see these are almost alpine-like glaciers here, some pretty stunning scenery. But also what I really enjoy is, you're going back and forth, it's a long day, taking a few moments out to just kind of stare out the window at the expanse of ice below you, try to get a sense for that scale of the kilometers of ice below and out in every direction. It's almost like a hot air balloon ride sometimes, it's so smooth. And then I guess on the way back, people are kind of catching up on their data processing. They're grabbing some meals they may have missed, maybe even sleeping, because you've got another big day ahead of you the next day. And here's the aircraft crew, getting the aircraft ready for operation the next day.
So what's the coolest thing you've seen?
Seen a lot of cool things. I think flying over this massive crack in the Pine Island Glacier, again, as deep as the Statue of Liberty is high, and then 8 times below that, below water, creating an ice about to calve off a giant iceberg the size of all of New York City. That was pretty cool. It was a crack that wasn't there a few days before we flew, and there it was, 20-some maybe kilometers long. So some cool stuff.
Thank you, Jefferson.
Sure thing.
So the IceBridge flight today is to Pine Island Glacier in West Antarctica. Ben, earlier this spring, NASA scientists and you and your colleagues published reports saying that this region of West Antarctica was in irreversible decline. What does that mean?
Well, what it means is that given the way we think that the ice is melting at the bottom right now, if it keeps going like that, in the next couple hundred years, the amount of ice coming out of that region will double, and it will keep going at that rate or a slightly greater rate for the foreseeable future. And if it keeps doing that, eventually we won't have much of an West Antarctic ice sheet left. So what we've found is that this glacier has been pushed to the point where if we keep pushing it like that or even a little bit less, ice will keep flowing into, ice will soon start flowing into the ocean faster, and then a lot of ice will leave the continent and end up in the ocean. Now, this isn't a huge immediate contribution to sea level rise. It's not like the oceans are going to rise up and swallow New York City next year, but it is a big change that we can be fairly confident is happening and happening fairly soon. So that was a result that we were able to do because we have new measurements of the ice thickness in this area. I guess there are two important things about it. We have measurements of ice thicknesses in the area, and we have measurements of height change that's ongoing in the area. Without the measurements of ice thickness, we wouldn't be able to predict with any confidence what might happen in the future. And if we didn't know that the surface was already dropping in this area pretty rapidly, there's almost no way that we would have believed the results that we got from our model. So these two things together are what we really need to understand what's happening in areas like this.
Another question for you, Ben. So we're talking about emissions studying changes in ice melting. What's driving these changes?
Well, probably the main thing that's driving changes in ice melt in West Antarctica is the way the oceans are flowing. So the surface temperature hasn't changed a whole lot on the Antarctic continent. But we see the surface going down, and we know that the ice is melting quite a bit more. So the way that has to be happening is that ocean temperatures have gotten warmer right at the bottom of the ice sheet, where the ice sheet meets the ocean. And when the water temperature goes up, it's very, very good at melting more ice. So we are pretty sure that there are areas where 150 meters of ice are melting off the bottom of the ice sheet every year. This is close to the grounding lines of Pine Island and Thwaites glaciers. And probably the increase in that melt over the last few years has driven the big changes that we've seen. We also know that the ocean has gotten warmer over the same period, and there seems to be a pretty fair correlation between the changes in the temperature of the ocean and the changes in the melting of the ice sheet. If you look on the Antarctic Peninsula, which is the thumb of Antarctica, so right there, the changes probably have a lot to do also with changes in the air temperature. Because we know that the air has gotten a lot warmer on the peninsula, even though it hasn't changed very much on the continent itself.
So, Ben, what happens to the world as we lose ice?
The big thing that happens is that sea level goes up. And when sea level goes up, places where there are a lot of people living close to the ocean can start to go underwater. I guess the big effects are places where the land is really flat near the edge of the water, and New Orleans would be a good example of that. A lot of places where people are living at the mouths of rivers, which are good places if you want to have a port, if you want to have commerce up and down the river, but they're sort of bad places to be if the sea level is rising. The other thing that happens is that storm surges get worse. So when there's a hurricane that pushes water up on shore, if sea level is higher, that storm surge can reach farther inland. So those are the things that we worry about as sea level rises. There are also some changes that relate to the changes in sea ice. So sea ice has declined tremendously in the Arctic. It hasn't changed much in the Antarctic. But as sea level goes away, that allows more heat exchange between the ocean and the atmosphere. And that can have a big effect on changing weather patterns. So there's a big component of IceBridge that measures changes in sea ice. In some seasons, they get about half the flights for the sea ice, and that'll also be an important set of measurements that ICESat-2 will do when it goes up.
So we've seen sea ice losses in the Arctic, but sea ice gains in the Antarctic. Why is that?
The sea ice losses in the Arctic are a combination of warmer weather and changes in the way that the wind is blowing, which have tended to be more effective at pushing ice out of the Arctic basin. In the Antarctic, it's not as clear what the change is that's leading to an increase in sea ice. Antarctic sea ice is different from Arctic sea ice in that it typically only lasts 1 year. In the Arctic, you can have sea ice that's trapped amongst all the islands and things that can last for decades, and so that can be important in sort of carrying over temperature changes from 1 year to the next. In the Antarctic, it's purely determined by the weather this year because it all goes away at the end of the year. So there are fundamentally different systems, and the way the Antarctic is changing it's an interesting topic for research right now.
By the way, we're answering questions from #IceBridge. I have a question for Ellen. What are NASA's future plans for studying the Earth's climate?
Just this year alone, we're launching 5 satellites. 3 of them have already been launched. The Global Precipitation Mission, that's measuring precipitation all around the globe, that joint project we did with the Japanese Space Agency. We've launched an instrument called RapidScat up to the International Space Station that's measuring tropical winds, which is important, obviously, for studying things like hurricanes and cyclones. We launched a mission called the Orbiting Carbon Observatory 2, which is measuring carbon dioxide concentrations. Where is it coming from? Where is it going? And then later this year, we are in the next few months, we'll launch 2 more missions, one to measure soil moisture all around the Earth. That's important for farmers who want to know about the health of their crops, where to plant crops, as well as trying to understand the water cycle. And we're going to launch another instrument to the space station called CATS, which is a cloud aerosol. Aerosols are little particles in the atmosphere that actually help clouds to form, and they're important for understanding both weather and climate. And you might say, wow, she just listed all these different missions, and they're measuring this and they're measuring that. That's what we do at NASA. That's why we have 17 satellites measuring different aspects of the Earth, because it's a very complex planet. So if you're trying to understand the climate, you need to understand and measure all of the inputs into the climate, which means what's the state of the oceans, what's the state of the land, what's the state of the atmosphere, which is why we need so many satellites, and then we supplement that with aircraft like IceBridge to really try to understand the complex system that causes our climate to function.
For those of you just joining us, you just heard from NASA's Chief Scientist, Dr. Ellen Stofan. Our next question is for Ben. What have been some of IceBridge's early contributions to polar research? IceBridge
has contributed a tremendous number of measurements of ice thickness to databases that people have for Antarctica and Greenland. There's been a new map of Antarctic bottom heights that's come out in the last 2 years, that has really done a great job of showing some details of the continent that we didn't have before. The same thing for Greenland. People have discovered a canyon. I can't even remember how it compares to the Grand Canyon. It's bigger. Under the Greenland ice sheet that was not evident before we had IceBridge measurements. It's also done a good job of showing us the changes that are happening both in Antarctica and Greenland. And so there have been some major studies reconciling measurements between Antarctica and Greenland of elevation change and showing that they agree with other sensors that we have. So they've really firmed up our understanding of how the ice sheet is changing and just what is going on in these places.
This one is for Ellen. What advice do you have for someone who would like to be involved with a mission like this? And this is NASA's Chief Scientist, Dr. Ellen Stofan.
You know, it's fun to me to see yesterday. I think this is one of the things that the ambassador and I really enjoyed yesterday was meeting all the different people who were involved in IceBridge. And of course, I have the fortune to meet all the people who work on different missions of ours, like our Mars missions or our astrophysics missions. It's all kinds of different people. You know, we have engineers who help build the instruments, who help monitor the instruments and take care of them, who've maybe majored in engineering, studied physics maybe. We have scientists who come from all different backgrounds, geology, biology, people who study glaciers, people who study chemistry of the atmosphere, how it interacts with the surface. We have, of course, the pilots on the plane, who these amazing pilots who did such a great job flying us around yesterday. We have people who help us tell our story to the public, who are just as much a part of the team as everybody else. So it's a huge range of backgrounds that help NASA accomplish the work that it does every day, and it was a great honor to be able to hang out with them yesterday.
And if I might add, when Dr. Stofan was talking to Chilean students here in Punta Arenas, you know, they're very interested. They wanted to know how to sign up for the next Mars mission. They wanted to figure out, you know, what it takes to be an astronaut, and that's really neat. You know, to have you know, NASA's chief scientists traveling around the world, talking to other kids here in Chile about the opportunities and the exciting projects that we have underway.
One of the things I say to kids all the time is, you know, we've got really tough things we're trying to accomplish, from how do we cope with the changes being caused by climate change, like sea level rise effects that we're already seeing around the world. You know, how do we solve the problems of getting humans down onto the surface of Mars? Mars has a really thin atmosphere. We need all the great minds in the world from all around the world. This is really an international endeavor, and that's why I like to go and be able to talk to students not just in the U.S., but all over the world, to try to say, hey, you know, come on, we need help. This is an international endeavor.
We have a Twitter question for Mr. Ambassador Mike Hammer. At Vero Clark asks, what was the first thing that came to your mind when you saw Antarctic soil underneath the plane?
Again, it's just truly amazing. I mean, you're just, it's a long trek even from here from Punta Arenas, so there's great anticipation for 2-3 hours, and then you see, it's like you're finally here, you're seeing it, and it's just tremendous, because then it goes on forever, it seems. I mean, you don't grasp it. I mean, you see it on a map and you see that, you know, Antarctica is pretty big, but when you're flying for hours and hours and all you see is a big white sheet of ice, it's really impressive. And it just gives you a much better sort of understanding of what is out there. So again, I wish, and again, you see it on the images, but I wish everybody could see it, because then you see the natural beauty, you see how important it is to protect our environment. I was struck, one of the things I have to say, I was hoping I'd see a penguin or something, but I didn't know this, but NASA takes great care in these IceBridge missions to not go over any penguin colonies, and in fact not affect the wildlife in any way. So no, we didn't see penguins out there, but we know they're out there. But we did see a lot of ice, and in fact, we can see penguins down here in Punta Arenas, just off the coast. There's a little nice reserve. So again, it's really neat to be able to, you know, as an American diplomat, experience something like this, and it makes me really proud to be an American to see the kind of work that we're doing.
We have another Twitter question. This one's for Ben, our senior IceBridge researcher at University of Washington, Seattle. Twitter question is from @SoBellWriting. Are any of your data sets being shared with other programs, and do you have any conclusions?
So all of our data sets are being shared with other programs. You can get them in one form or another from the National Snow and Ice Data Center. So IceBridge has a commitment that 6 months after any flight, all of the data become available over the internet to anybody who wants it, and that's anybody who wants it. So if you want it, you can go get it. The data sets, some of them are easier to use, some of them are harder to use, but they're in formats that are designed for scientists who are really interested in all of the data and for really being able to squeeze as much as they can out of these data sets. For conclusions, you know, we had a paper earlier this year that was looking at Thwaites Glacier that built a model of how Thwaites Glacier could evolve over time. We've done the same thing for Pine Island Glacier and for Jakobshavn glaciers in Greenland. So we have some papers that combine the measurements that we've taken with IceBridge with computer models to try and really understand what's going on now and what can happen in the future. I think that this is just barely a start, and it's also just me talking off the top of my head about the studies that I'm most aware of. There are over 140 IceBridge publications, more like 150 IceBridge publications in the scientific literature. You can find those, like I just did, by Googling IceBridge publications, and you see this really long list of papers that people have published using these data. So they're really jump-starting a lot of research by a lot of different researchers. Probably half of it or so is American research, but there's also a lot of European researchers and Japanese researchers and others who are using these data. So it's the start of collaborations around the world that we're making with these data sets.
For NASA Chief Scientist Ellen Stofan, here we have a question via Google Plus from Max Blum. Once we've made necessary observations to achieve a certain understanding of the health of the polar bears and oceans, what as humans can we do to remedy those conditions?
Well, I think the most important thing is for all of us to reduce our carbon footprint, and you know, there are lots of ways individuals can do this, from reusing, reducing, and recycling our consumption. But clearly, it's going to take more than that. It's going to take a worldwide effort of people changing their behavior, and it's something that's very hard as humans to do. It's hard for all of us to do. But certainly, the president has made clear that it's a priority, that we need to start dealing with climate change, not only in preparing for the effects of it, because sea level already is rising. It already is affecting towns, for example, in Florida that now have to, at high tide, they're having to pump out streets on a regular basis. So climate change isn't something that's in the future, it's happening right now. And so being able to mitigate the effects that are already occurring is part of it, but then changing our behavior so that in the long run we can reduce the amount of carbon dioxide we're putting into the atmosphere is critical.
For Ben and Ellen, what drove you to careers in science?
I'll let Ellen take that first.
I'm kind of an unusual story because my father worked for NASA and my mother is a science teacher. So my sister's a lawyer, so it didn't affect everyone in my family. But for me, science was just something always that I loved. I was one of those kids that was picking up every rock and shell that I could, and I always really liked rocks. These guys can tell you today we went to a museum and I got to look at fossils. I got really excited. And growing up with my father working for NASA, I realized I could combine my love of geology with space and be able to study, for example, I study volcanoes not just on this planet, but on planets all around our solar system.
I've always been interested in science and technology. One of my first memories of a science project was that at my preschool we got to take apart a typewriter. And it was something that everybody could do, but I elbowed every single other kid out of the way so I could do it myself. But all through high school and college, I've been interested in taking science classes in a lot of different fields. But it was after I graduated from my undergrad that I got offered a chance to go to Antarctica if I would do a master's degree in glaciology. And so I immediately said yes, and then thought, gosh, what is glaciology? But as I learned more about it, I quickly got hooked because it's a great branch of science. It's something where you are looking at changes in the Earth that are happening as you watch. And a lot of people who study, Precambrian fossils, who study the motion of the plates of the Earth, can't see the changes happening. But we can watch and see in a year or two big changes in individual glaciers. And it's really exciting to watch how that happens from year to year. So it was extremely addictive, and I haven't gotten free of it since.
We have another question for you, Ben, our senior IceBridge researcher, and this is from Craig Landon on Twitter. How long before you can gauge the state of the West Antarctic ice sheet? Will these flights gather more data?
So these flights are expected to continue until IceSat-2 launches, and then they'll go for a year so that we have measurements on the ground at the same time IceSat-2 is making its measurements. So we'll be able to calibrate the satellite and make sure we understand what it's telling us. And then we'll have a series of continuing measurements from IceSat-2 off for 3 or more years. But really, we need to watch these ice sheets on an ongoing basis because there are a lot of different things that they could do. We have a picture, we have snapshots in time of what the ice sheets are doing right now. We have models that can try to predict what they're going to do in the future. But one thing that we've learned is that there are always surprises. If you think that you can predict what the ice sheet is going to do, you often turn out to be wrong if you wait a couple of years. So it's going to be an ongoing effort to keep an eye on what these ice sheets are doing and make sure that we know what that's going to mean for human life.
Now, Ellen, our NASA's chief scientist, could you tell us a little bit more about IceSat-2?
Well, you know, it's really exciting because, again, obviously being able to have that global view as opposed to IceBridge is doing a great job, but we're under the force of the weather. So on days where the weather's bad, we actually can't go ahead and fly because we need clear weather for our laser altimeter to be working. And so while the data we're gathering is extremely important and it does bridge this gap, being able to have a satellite up in permanent orbit, being able to take data in both the Arctic and the Antarctic all the time is critically important. And so we're in the process of building the instruments. For IceSat-2, those instruments will be highly capable, making many of the same measurements that IceBridge is making, but again, now doing it on a much more regular basis. As Ben said, it's really critical to monitor this behavior month to month, year to year, and so getting that satellite up there is something we're really looking forward to in 2017.
We have another question for Ben from Ernacio via Twitter. What is the importance of ice shelves and their buttressing effect in tributary glaciers?
Wow, that's a good question. So ice shelves are where you have a glacier that flows out onto the ocean. So if you can imagine a glacier flowing downhill until it gets to the coast, when it gets to the coast, ice floats, so it will sometimes flow out onto the ocean and make a big flat area of ice with water underneath it. And if you look at these animations, often it's hard to tell from the animation where the ice shelf is. And there we go. So you see that dark line. Everything on the ocean side of that dark line is floating. And that ice plays an important role in deciding how fast the glaciers upstream flow. Because for ice to flow off a glacier onto the ocean, some of the ice shelf ice has to get out of the way. Now, if the ice shelf gets thinner or if it breaks up, then it's much easier for ice to flow off the continent onto the ice shelf. And that's probably one of the reasons why the glaciers have been flowing faster over time, because the ice shelves have gotten out of the way and the ice sheet has an easier time of the ice has an easier time of leaving the ice sheet into the ocean. So that's what we call buttressing, when the ice shelves are preventing ice from flowing out of the glaciers into the ocean. And so we're keeping a good eye on the ice shelves to try and see how that might change over time.
Now, I have a question for Ambassador Hammer. How did you get interested in your position?
Well, I actually grew up overseas with my parents in Latin America, and I really enjoyed living abroad and learning about other cultures, learning languages like Spanish. My mother is from Spain. And I wanted to serve the country, and I thought that it would be really neat to be working at our embassies and serving in that way. And so I went to Georgetown, and where they have a program in international affairs, and then I went to graduate school, and then I was lucky. I took the Foreign Service exam, and they let me in. And I encourage anybody who wants to join the Foreign Service to at least take the exam and see if perhaps they might offer you a job. It's really exciting. You get to travel around the world, meet really interesting people. Yes, you get a bit homesick at times, but now through all these digital platforms, whether it's now Snapchat, FaceTime, and whatever else, you can connect with folks back home. But it really is something that's very special in terms of what we're able to do to explain America to people around the world. And frankly, I think we want to see more students, American students, studying abroad as well. And President Obama launched a program. It's called 100,000 Strong in the Americas, where he's trying to encourage Americans, 100,000, to go into Latin America and the Caribbean and study, and also Latin Americans to come to American universities, because it's those personal people-to-people exchanges that promote better relationships. And so, in a way, when we travel abroad, everybody's a bit of an ambassador representing the country. And that's what you want to see. You want to see a promotion of good relations between people. I very much enjoy it. It's a real honor to be representing the President and the American people here in Chile. It's a fantastic place, and look at the incredible things I get to do. Going on an IceBridge mission, overflying Antarctica, going to great lectures with Dr. Stofan and meeting kids who are really excited about the prospects of science, and then working with my colleagues. Here we are in an American corner in Punta Arenas, so we have our Chilean friends who are running this at the University of Magallanes, and again, we're connecting with people, and ultimately we're doing what we can to make the world a better place as we promote America's interests around the globe.
We have another question for NASA's Chief Scientist, Dr. Ellen Stofan, from Roberto Flores on Twitter. He asks, can NASA detect gold, precious metals, and gems under ice shelves?
No, we really don't have the ability to do that, because underneath the ice shelf is water, and any kind of minerals or gems would be at the bottom of the ocean. And right now, from space, most of our techniques, like radars, that get us through the ice shelf, which is what we're using on IceBridge to get, as Ben talked about, to get that thickness and look at the layering in ice shelves or ice sheets. That radar that sees through, when the radar gets to water, it just scatters away, and so that you can't actually penetrate down. We use different instruments in different parts of the electromagnetic spectrum to look on land for different rock compositions. That's hard to do when there's a lot of vegetation in the way. That's why I like looking at planetary surfaces like Mars or Venus, where there's not all these trees and plants all over the place that get in the way of looking at the rocks the way a geologist wants to do. So looking at those compositions we can do in some areas, but always just on land.
We have another question for Ben. What are the different types of ice that IceBridge looks at?
So there are two main types of ice that we look at. There's ice in the ice sheets and ice shelves, which is ice that's fallen from the sky as snow and then over the years gotten squished by its own weight until it turns into ice. That was snow and now it's ice. And there's sea ice, which is either frozen ocean water or snow that's fallen on top of frozen ocean water and turned to ice. They're quite different in a lot of ways. Sea ice is usually much thinner, so thick sea ice might be 20 feet thick, and we would see thick ice like that in the Arctic primarily, whereas ice sheet ice and ice shelf ice can be more than 2 kilometers, more than 3 kilometers thick in some cases. So the other big difference is that ice sheet and ice shelf ice is very fresh, so there's not a lot of salt in it. In fact, it's some of the cleanest water you're likely to find. So radar travels through it very nicely, whereas with sea ice, that can be almost completely opaque to radar energy. So in some cases, you send down a pulse of radar energy, it doesn't make it all the way to the bottom of the sea ice, even though it can make it all the way down 2 kilometers into the ice sheet. So those are the main types that we see.
So you were just hearing from Ben Smith. He's our senior IceBridge researcher. We have another question for you, Ben, about the flights from Twitter. Since it's at the bottom of the world, how do you know which side of Antarctica is the west side?
Well, there are two ways that we call that. Two reasons we call that the West Antarctica. First of all, it's in the Western Hemisphere. So if you draw the line for the hemisphere all the way around the pole, it pretty much splits West Antarctica from East Antarctica. There's also there's kind of a standard map that you make of Antarctica, just like is showing on my screen right now. And in that map, West Antarctica is on the the left side of the map, which corresponds to the west side when you're looking at a northern hemisphere map. So, and the dividing line between West Antarctica and East Antarctica is the Transantarctic Mountains. You can see those coming up from the bottom of the screen to the middle of the ice sheet. They continue under the ice sheet all the way up and become the Antarctic Peninsula. So that's the major geologic division between West Antarctica and East Antarctica.
Thank you. We have a question for Mr. Ambassador Hammer. What is the position of the U.S. on protecting the glaciers?
Well, there's an Antarctic treaty that we're a party to, and where we work with other countries in terms of trying to preserve the purity and the nature of Antarctica, while at the same time we're doing research. So there are certain protocols that, of course, NASA abides by, that we do in terms of international cooperation. We don't recognize any claims over sovereignty over parts of Antarctica, but we see it as a way that, again, the international community can do research that allows us to learn about, the issues like climate change. So, in essence, we want to do everything that we can to preserve it as it is, but to learn from it as it is. I don't know if Dr. Stofan has anything further on that.
No, and certainly the president's extremely concerned about climate change, and he's been doing a number of things. He just at the most recent climate summit at the UN announced 5 different initiatives to try to mitigate the effects of climate change, try to deal with climate change. It's been a big priority, and it continues to be.
We have another question for Ben Smith. Is IceBridge daytime only flights, or do you get to see aurora? How often do aurora occur?
Well, I have to admit that I've never been on an IceBridge flight. But I was there in Greenland this spring, in the town where the IceBridge plane was based, in Kangerlussuaq. And I know that they did see aurora the day before I got there. So I didn't get to see it myself. And then over the next couple of days, the days got long enough so that the sun wasn't really setting anymore. And at that point, there was no aurora. So the IceBridge starts pretty early in the spring, and so they must have a chance to see the aurora some of the time. But a lot of the time when IceBridge is flying, the sun is up all day long and all night long, and they probably don't see a whole lot.
Now, I have a question for both Ambassador Hammer and Dr. Ellen Stofan, who had the privilege of going on the flights. How cold were the flights?
Oh, they're chilly, all right. They've gotten a little bit warmer. Your feet tend to get a little bit cold, but they try to make it pretty comfortable. And there's tons of coffee, so you're drinking a lot of coffee, keeping you warm. So, and so it's. I didn't think it was that bad.
No, it really wasn't that bad. I must say, I had brought some mittens along. I had an extra jacket. So I was prepared for it to be even colder than it was. But you're up moving around. The flight was very smooth, so the seatbelt sign wasn't on most of the flight, so you could wander around and talk to people and, as the ambassador said, drink a lot of coffee.
One neat thing that we did do is that we did go into the belly of the plane. I guess they call it the pit, and we saw how they have this laser array, and it's really incredible to see. And there it was actually rather chilly.
But you can see from the video there are people in shirt sleeves on the airplane. Some people are a little tougher than others. I pretty much kept my multiple sweaters on all day, but it wasn't as bad as I thought it was going to be.
All right, so we only have a couple minutes left, so I would like to ask Ellen what's next for ice study for NASA.
Well, certainly we're looking forward to the rest of the IceBridge season. We have a lot of tracks left that we want to fly. Again today, very exciting. They're flying over Pine Island Glacier, which we've been talking about a fair amount today. We have a lot of tracks left that, fingers crossed, the weather over Antarctica will stay clear a lot in the coming weeks, and we'll be able to accomplish those flight lines. Right now, as Ben mentioned, we have IceBridge flights planned through at least 2018, and that again is going to be critically important to bridge this gap until we get IceSat-2 up and running. And so certainly for NASA, continuing to assess the state of health of the ice in Antarctica, the ice in the Arctic is something that's a high priority we will continue to do. Because I think one of the things that people don't realize when they think about the measurements we make is how important that continuity of data sets is. You know, you can make a measurement this year, but if you don't know what the answer or what it was like 5 years ago, 10 years ago, 20 years ago, it's a lot harder to understand what might happen in the future. So the fact that we've been making IceBridge measurements for so long now, we have ICESat before that, gives us these long-term data sets. So it's so important to continue those out into the future.
Well, thank you so much, Mr. Ambassador Michael Hammer, our U.S. Ambassador to Chile, and Dr. Ellen Stofan, NASA's Chief Scientist, both calling in from Chile. And thank you, Ben Smith, our Senior IceBridge Researcher, calling in from University of Washington. Been a real privilege and pleasure having you here. Thanks everyone for coming out and for checking out this Google Hangout. Will be saved forever on YouTube, and we'll be posting the link shortly.